This is the tutorial for Chapter 10, Section 4, 0 and negative exponents, day number 1. So on our first problem here, we're going to end up evaluating the expressions. And so what that means is we're just kind of come up with a one-number answer. It can have exponents in there sometimes, depending on how big the number is. If the numbers are small enough, we'll go ahead and multiply them out. So let's take a look at some components we need to worry about, which, first of all, is 0 as an exponent. Well, it says for any non-zero number, a to the 0 power equals 1. The power of 0 to the 0 is undefined. And so how is that the case? How is 4 to the 0 power 1? Well, let's take a look at a concept here that we'll be looking at today, which is dividing expressions with exponents. And so let's say we had this. 4 to the second power over 4 to the second power. If I was to write this out in an expanded form, I would have 4 times 4 on the top of the fraction and 4 times 4 on the bottom of the fraction. Well, when I go ahead and cancel out common terms, you see how the 4 divided by 4 makes 1. And when I cancel out this 4 over 4, that makes 1 as well. And when I multiply 1 times 1, I get 1. Well, that's okay, I understand that concept, but how is 4 to the 0 power 1? Well, let's go ahead and take a look at a rule. So when we are dividing expressions, we see that if we had, let's say, 4 to the third power over 4 to the second power, what we would end up doing is the same sort of thing. We would go ahead and write this out 3 times and write 4 out 2 times here, and we'd end up coming up with that same concept of canceling out terms, and we're just left with 1 4. Well, 4 to the first power. Well, there's another way we could end up doing that, and you might see it on this next example here. So let's say we had 4 to the fourth power over maybe 4 to the second power. You see here, I go ahead and write out 4 4s on top of the fraction and 2 4s on the bottom. Well, I'm canceling out these common 4s, and now I'm left with just 2 4s on top. Well, okay, so what we could have done is we could have subtracted the exponents when the bases are the same, because that's basically what I'm doing here. You see how the 2 4s here are canceling out 2 of the 4s on top, and so I can always subtract the exponents. And so I could do the same thing here. I can subtract the exponents. I could take these 2 4s away from 2 of the 4s on top, and that leaves me with 1 4 on top of the fraction. Well, I'll do the same thing here, and notice that when you take 2 4s away from 2 4s, 2 minus 2 makes 0, and that's how I'm getting as 0 as an exponent. And you see, whenever you have a number expression with the same exponents as you have on the bottom with the same base as well, you always end up canceling all the terms out, and you're left with 1. So anytime we have a number to the 0 power, it's going to end up being 1. Well, here we have negative exponents, and sometimes if we use that rule, like let's say we had 4 to the negative, or actually let's say 4 to the fourth power over 4 to the sixth power. And so when we do that, we'll go ahead and write out these 4 4s on top, and then we have these 6 4s on the bottom. And when we go ahead and cancel out these 4s, this time we've got more 4s left on the bottom of the fraction. And so notice how everything canceled out on top, and we're left with the number 1. Down below, these 1s multiplied by 4 times 4 make 1 over 16, which is the same thing as 1 over 4 squared. Well, how could I get that using exponents? Well, the exponent rule would say, well, you subtract the exponents. We subtract these 6 exponents from 4 exponents, but you see you're getting a negative 2. So whenever we have a negative exponent, it's just the reciprocal of those positive exponents, and that's what the rule says. For any number, for any integer n and any non-zero number a to the negative n is the reciprocal of a to the n. So you see how 4 to the negative second power is the reciprocal, and is the 1 over 4 squared, and that's what we end up seeing in this example here. So on this first one here, we notice that we have the same base, same number of exponents. So we're going to cancel out these 7 a's on the bottom with 7 a's on top, and that's going to leave us with 0 a's left over. And so we know that number is just 1. Well, over here we can use the rule which says that when we're multiplying, we add the exponents. So I'm going to keep the negative 2 in parentheses to show that's the number that I'm multiplying out. And when I have 8 or negative 2 to the negative 8th, I'll go ahead and add on the other set of 8s, and you see you get a 0 as the exponent again. And it doesn't matter that this number is negative. Whenever we take negative 2 to the 0 power, we've got the same number of negative 2's as we have on the bottom, so that's going to just make the number 1. Well, on this problem, we've got the 3 4's on top and 5 4's on the bottom. So a couple ways to do this problem. We can use that rule of just subtraction, and if we do that, we'd end up with 4 to the negative 2nd power. Whenever I have a negative power on top of the fraction, that just means the reciprocal of positives. So it represents 1 over 4 squared, which is 1 over 16. Well, the other way to do that, whenever you've got just positive exponents, just think of this as 3 4's on top and you got the 5 4's on the bottom. You know that you're canceling out some 4's, and there's more 4's left in the bottom of the fraction because the number, the exponent, is bigger. And so you can automatically just see that there's 2 4's left in the bottom, which would make 1 over 16. So when I see this problem, rather than doing the subtraction the correct way, which is to subtract the top or the bottom from the top, I would end up doing it this way. I would just cancel out and say, well, there's more 4's on the bottom, so I'm just going to cross out these 3 4's and subtract from the positive number of 4's on the bottom of the fraction, and that would leave me with 2 4's on the bottom, which gives me that same exact answer. So on this problem, what I would end up doing is just multiplying straight across. I've got 1 times 1 is 1. 5 to the negative 3rd times 5 to the 6th. You're adding up the exponents when you multiply. So in this case, I see that, well, I've got more positives than negatives, so I'm going to end up subtracting, and I get positive 3 as the exponent. So 5 to the 3rd power, but that's on the bottom of the fraction, so that would end up making a 1 over 125. So in this problem, we've got order of operation to deal with, but when we do this, we can't multiply out the 2's because they have the negative exponent. So we need to think about where they're at. So whenever we see a negative exponent, that tells us that it's the same thing as the reciprocal of positive exponents. So that problem would look like this. So if I go ahead and keep that 4 times by, and then I'll go ahead and work those exponents, 2 to the 4th power makes 16. And now I can go ahead and do the multiplication. So 16 goes into the 4 2 times, or 4 goes into the 16 4 times. So I'm left with 1/4 plus 5. Well, 5 plus 1/4 makes 5 and 1/4. And that would be our answer. Well, one last problem here, and it's this problem here that deals with sand, and it says that the mass of a grain of sand is about 10 to the negative 4th grams. So about how many grains of sand are in the bag of sand. So it says right here there are 10 kilograms of sand. So 10 kilograms per bag. And what we're going to end up doing is we're going to divide by the number of grams that 1 grain of sand has. So that would be 10 to the negative 4th grams. But our problem is that you see how we're in grams here, we're in kilograms here. So we need to modify this equation a little bit. We need to go ahead and change these kilograms into grams. So I'm going to erase this line here first, and I'm going to modify this equation. So I know that there are 1,000 grams per kilogram. So I'm going to go ahead and multiply this by 1,000 grams per kilogram, and the kilograms will cancel out. So what that tells me is when I multiply this out, I get 10,000 grams per bag. And so what that is if I was to write it using exponents, you just count the zeros. 1, 2, 3, 4 zeros. So that's going to be 10 to the 4th grams per bag. So now what I'm going to do, now I can compare the two numbers because I have the same value, same type of units. I'm both in grams. And so what I'm going to do is I'm going to take 10 to the 4th grams, which are the grams in one bag, and divide it by the number of grams, the mass of 1 grain of sand weighs. And so it's 10 to the negative 4th grams per grain. And so when we go ahead, and this is grams per bag as well. And now, the reason why I'm going to do this is because if you look at it, this is a division problem. And if you think about it as a problem like this, 10 to the 4th grams per bag, and I'm dividing by 10 to the negative 4th grams per grain. And so whenever you divide fractions, you end up multiplying by the reciprocal. So notice how the 10 to the 4th grams per bag stays where it's at by multiplying by a grain per 10 to the negative 4th grams. And see, then you'll see how the grams cancel out and you're left with grains per bag. And that's what we want. So in this case, I end up having this 10 to the negative 4th. Now, two ways to do this. You can either say, well, anytime I've got 10 to the negative 4th, I could just take its reciprocal and then it becomes positive. And then I'll end up multiplying. I get 10 to the 8th power. And so that would be 10 to the 8th grams or grains per bag. So that's one way to do it. The other way to do it is to use the rule. So the rule says, well, you subtract the denominator from the numerator. So if I subtract this, I'm going to write minus negative 4. I subtract the exponents. But again, I'm taking away negatives. Well, whenever you take away negatives, you add positives. And so you get the same exact answer. 10 to the 8th grains per bag. Or in there, grains per bag. So two ways to solve that, and those are the problems that you're going to end up seeing on tonight's assignment. Good luck.